Hello everyone, welcome for this lecture. Today we are going to discuss equal area criteria, of a power system. So before going to study this, we have studied earlier, that is the swing equation of a power system, which is indicating or which indicates us to know that the system, whether it is stable or not, means under stability of the system can be identified by this swing equation. Okay, now as we have discussed, solving swing equation is a bit tedious. Okay, so we have a lengthy process called step-by-step process. In that we have Euler's method and Runge-Kutta method and all. Okay, without solving swing equation and getting it to know that this system is stable or not by solving this swing equation, instead of going for that lengthy process, what we can do is, so by this equal area criteria method, okay, by this one we can say that whether the system is stable or not. Okay, so let's see how we can say that by you, but we are using this swing equation only, but we are not solving the swing equation. Okay, without solving swing equation but we using swing equation, we are going to say whether system is stable or not. Okay, we'll see how this can be done. Okay, let's consider the swing equation of a power system. So what we can do is multiply this equation with the 2 by m d delta by dt on both the sides. When you multiply this one for this equation, we get, observe, we are going to multiply with 2 by m into d delta by dt. So for this side as well as for this side, when you multiply, you will get left hand side 2 by m d delta by dt, m into d square delta by dt square, and then at this side it will be again 2 by m d delta by dt into pa. Okay, so this one, what we can write is, this m and m get cancelled, right? So this 2 into d delta by dt into d square delta by dt square equal to 2 by m d delta by dt into pa. Observe this term. Okay, so just let it be, just consider this equation. Okay, suppose if you have taken differentiation of x square, how we are going to do the differentiation of x square will be like 2x into dx by dt, right? So this is our equation, right? Similarly, what we can do is, in this equation, and okay, in this part, so just assume that x is equal to d delta by dt. If it is so, then observe 2x dx by dt is nothing but your 2 dt by d delta into again differentiation of dt by d delta is nothing but your d square delta by dt square. So therefore, by comparing these two equation, okay, what we can write is, so this we can write, that is 2 into d delta by dt into d square delta by dt square can be written as differentiation of d delta by dt square. Okay, so this equation you substitute in this equation. Okay, so we get differentiation of d delta by dt whole square will be equal to 2 by m, this is the right hand side as it is. Okay, 2 by m pa d delta by dt. So now what we have to do is integrate on both the sides. Integrate on both the sides with respect to t. If you do integration of this, is get cancel these two, so it is d delta by dt whole square will be equal to 2 by m, keep as it is, those two are constant terms. Okay, integrate this, that is nothing but your pa, integration of pa, okay, d delta by dt into dt, because we are differentiating with respect to dt. So here these two get cancelled. Integrations, we have taken corresponding values of that, okay, from a minimum value to maximum value of delta. So it is a delta naught, it is the starting delta, okay, and the delta value, maximum delta value we don't know, so whatever may be the value, let it be. Okay, so from delta naught to delta we are calculating. Okay, this equation if you simplify, we get d delta by dt whole square will be equal to 2 by m. So this dt get cancelled, so it will be integration of pa into d delta. Okay, this is a square, if you remove the square, we will get a square root of same term. Okay, so what we know, for the system to be stable, then d delta by dt should be equal to 0. This we have seen earlier. Okay, substitute this term in this equation, that is, so this entire term square root of, Okay, this is the square root of 2 by m integration of pa d delta will be equal to 0. So then square root will, you can send this side, or 2 by m goes to 0. Then what remains is your PA, integration of PA with respect to d delta will be equal to 0 along with the limits. Okay, delta naught to delta. So what we can do is, so observe in this, PA is nothing but your PE minus PS, right? So this is the acceleration power. Acceleration power PA will be equal to electrical power minus mechanical power. Okay, so when you substitute in this equation, what will be there? If you substitute PA value as PE minus PS into d delta equal to 0, then integration is for both the sides. Okay, therefore it will be integration of PE will be equal to integration of PS. We know that what you mean by integration. Integration is nothing but, the physical meaning of integration is the estimation of the curve area under the curve. Okay, so what we can do is, based on this, okay, we based on this integration means area of the curve. Okay, this system is, we can say the system is stable or not by taking P delta curve also, that is the power angle curve. Based on that power angle curve, so area can be calculated by this integrations, and by using a power angle curve we can identify where exactly the area of each of your electrical power as well as your mechanical power is identified, and based on those two, if those areas are equal, okay, area of electrical power and area of your mechanical power are equal, then we can say that it is a equal area criteria. Okay, if those two are equal, then we can say it is equal area criteria, and based on that we can say system is stable. If those two areas are equal, then we can say it is stable, and we cannot say it is equal means system is stable based on this equal area criteria only on that A1 is equal to A2. Okay, till what limit we have to vary this load, means whatever it may be, sudden changes are happening in the system, till what we can do it, and then how to find out. Let's deal with in detail. Okay, let's start with this. So this, what we can say is the its means equal area criteria has more applications. Among that we are going to discuss few. Okay, let's discuss the application of equal area criteria. As we know, the equal area criteria is used to determine or to decide whether the system is stable or not without solving swing equation, but by using swing equation. Okay, so let's take a few what are the changes. Okay, so or faults you can say. So one, you can assume sudden change in the input. Okay, sudden loss of the one of the lines in the parallel lines, and sudden short circuit on the parallel lines. Okay, so based on this we can get. Okay, let's take first one, sudden change in the input. For that, consider for this one we can discuss in detail by considering one line diagram of a synchronous generator connected to an infinite bus. Okay, so here what you can assume is, let's take the synchronous machine working as a motor. Okay, so now what we can do is, which indicates that which delivers a mechanical power. Let's draw its power angle curve. Okay, this is the power angle curve of a synchronous motor. Okay, as it first indicates P electrical power, and this is the delta versus P. Okay, now we'll take, initially we'll assume initially there is some load on the motor, that is indicated as P naught. Let's take it as the initial power. Okay, initial output power. Okay, so what we can do is, remember this is your electrical and this is your mechanical, what you are putting on that. Okay, so now initially some load you have put, so that is P naught, it is P naught. Okay, so corresponding to that is a delta naught. Okay, and the initial conditions means what happens is system will be at a steady state condition, whereas your omega r is the rotor speed, omega is your field speed. Okay, so remember, at the beginning initially there is no fault at all, so system will be under steady state, then omega s and omega r will be rotating under synchronous speed. Okay, so then after suppose if you put certain load, okay, After some time, if you put a load, that is if you increase the load, okay, to a PS, right, this is your increased load. What happens is PS is increase, okay, as you know, PS is increases. What happens when a PS is increases? What about your acceleration power? That is a PA. PA is what? PE minus PS. Okay, so when PS increases, so difference between these two decreases, so acceleration power will be start decreasing. Okay, so what happens here is, so your electrical power, okay, so that if PS is increases, then PA will be negative. Okay, PA will be negative because this is more than PE, therefore PA will be negative. This indicates it is a deceleration. Okay, when rotor starts deceleration, observe the angle delta is here. This one is a delta. Omega s starts rotating in its own speed, but rotor omega r, because of this PA negative, it starts decelerates, means slowly it lags behind your omega s. When omega r is lags, so obviously it is moving in this direction only, I'm saying you that just it is lagging behind this. Then what about your delta? Delta start increases. Okay, delta is nothing but your torque angle. Okay, that is starts torque angle, or you can say load angle, start increasing. Okay, till the point B. Okay, till the point B. And then what happens when, okay, till the point B, and then what happens if delta is increasing? It means your alpha start increasing. Okay, acceleration speed is goes on increases. And then what happens there is PA is decelerating, means, so what happens there is PE takes an action to starts increasing. You can observe here PE is start increasing. Okay, so then what happens is till at B omega r will be at minimum condition. Okay, at a minimum. After certain time, what happens, omega, once it reaches at B, after certain time, means after B point, your omega r start increasing. Okay, but omega r start increasing, but it cannot be equal with omega s. Okay, even though it start gradually increases, but still it is behind the speed of your omega s. Okay, then also your delta you may say it is increasing, but it is not equal to that. Okay, it is not less, so it is increasing slowly. Okay, so therefore still this much also means till this point B, your omega r will be at a minimum position. Okay, once it reaches to a minimum, and then it takes a part, and then omega r starts increasing. Okay, after certain period, your omega r start increasing. When omega r start increases, okay, your delta start decreases. Okay, your delta start decreases. When both the reaches, okay, when both omega r and omega s both are equal in a speed, then delta remains constant. After reaching constant, it reaches to a point C. Okay, at C your delta will be remains attains a maximum value, and it remains constant. Okay, so when it happens, after that, whether omega r increases or increases more than your omega s, then also your delta is not going to change. So what happens there is, after certain time, your omega r is going to dominate your omega s. Okay, so then what we can do is, so based on this till C we have calculate, means we have seen how your omega r will be. Okay, so that what we can do is, under the consideration of this, we will consider area of PE and what is the area of your PS. Area of electrical power and area of your mechanical power will see. So when it reaches to a C, this observe A point we have observed, B point we have observed, C point also we have observed. So PS is at delta S. Okay, so when it is reaches to C, it is at delta M. Okay, so let's indicate this as, like, in this. Okay, so in this you extend this line, This you can indicate as A, B, C already you have taken. Let's indicate as D, and this point let us indicate as E. Okay, so observe what is the mechanical area and what is the electrical area. Okay, so consider both mechanical area and electrical area. Okay, once you consider electrical area and mechanical area, right, we can write your electrical area is area of electrical and area of mechanical. We'll write electrical area. Okay, here this side will write electrical area, that is starting from a delta naught. Okay, delta naught A, right, and then reaches to B, and then reaches to C, and then reaches to E, and then reaches to delta M. Okay, and let's consider your mechanical area. Okay, power at a mechanical area. So if you consider this one, okay, so here we can observe this starts from delta naught obviously. Okay, it starts from delta naught and it is going to reach at A. Okay, and it is going to reach at D. Okay, it is a mechanical power, and then it is going to come at B, and it is going to come at E, and it is going to come at delta M. Okay, these two are your areas. Now let's remove common areas. Let's remove the common areas: delta naught, A, B, E, delta M, and delta M. Which all the areas are remained here? Okay, C area for electrical and D area for mechanical. Okay, C and D. Observe this. Okay, so in this you can observe, right, D is for mechanical and C is for your electrical. So suppose this area you can consider as A1 or A2, or you can take A1 and A2. So if these two areas A1 is equal to A2, then you can say that a system is under stable condition. Okay, so and then till what it will be means equal, system is stable, we cannot say all the time. Okay, suppose if you increase this, okay, you can observe in the earlier one, and then we'll come back to this. Okay, suppose here, see, observe, this is a PS. If you increase this, see, now till this much we have a area to increase the load. Okay, if it comes here also, there is still this much area portion is there to cover it back. Okay, again also we can say system is under stable. If you put some more load, then also sometimes we can say yes, but if you put bit more load, then this starts decreasing, area of that will be start decreasing. What happens there is, so such conditions are called as critically stable systems. Okay, suppose if you increase the PS much more, area of this one will be start decreasing. Okay, sorry, not that one. So even though if you say A1 area 1 and area 2 are equal, but capacity of sustaining your electrical power will be lesser than that of your mechanical. Okay, it is not with respect to area, I'm sorry, right? So you, during this such conditions, your system will be under critically stable even though areas are equal. Okay, so suppose if you put a load more, then what happens there, the system will be under unstable. Okay, then there is no matter of speaking your areas are equal or not. Okay, till maximum load can be put. Okay, this has to be visible for us, means electrical power can be present there to compromise or to satisfy your mechanical power. Okay, I hope you understand. This is one of the application of equal area criteria. Okay, thank you.